Everybody. So I'm here from TNR, and on behalf of our North American partner, which is Power Source Instruments. They're based very near Mississauga and Toronto in Canada. So today what I'm going to do is talk about relay testing and one of our solutions that we have that will assist with the relay testing. I think Mark wanted to just give a little brief introduction on Power Source.
Great. Mark, are you there?
Yeah, I'm here. I think Randy took care of that, unless there's something else that we want to share. We're
No,
just
that's
basically
great.
the local. Yeah, we're the local reps here in Ontario. So any support or any needs that you have here locally, we're here to support you.
Okay.
That's all. Thank you.
Right, I'll start with the, as I say, part of the show will be part of a little brief introduction on TNR test equipment, because I'm guessing that many people in North America and Canada may not be familiar with this. So as we said, I'm the commercial sales director for the company. I started with the company in 2017, but started in the test equipment industry back in 1993. The company itself was formed in '82 as a sister company to a company called Transformers and Rectifiers Limited. And as their name suggests, they make transformers and rectifiers, but they make very special transformers and rectifiers that are problem solving. We ourselves, we design and manufacture and sell both high voltage and high current test systems. In 2020, we acquired a company called HVI, which is an offshoot from Edgecombe or Metrome, and they have a range of products, including live line testing kits, high voltage indicators, high voltage detectors, HV phasing sticks, DC high voltage test solutions, and we also do a capacitive test point voltage detector that goes on the back of the cable connection point, as you can see in the picture up on the top of the left hand side there. So what we're going to do is talk about relay testing function relay function and testing. What is a relay? Where does it fit into a system, and how do you test it correctly to ensure that you've got protection on a system? So in electrical engineering terms, a protective relay is a relay device designed to trip a circuit breaker when a fault is detected. It effectively acts as a circuit breaker lookout. So what it does is it monitors the circuit, and if it sees something untoward, and that can be anything that you've designed the relay to look for, it will tell the circuit breaker to operate and therefore protect the system. The first protective relays, they were electromagnetic devices relying on moving coils, operating on moving parts, and they provided detection of abnormal operating conditions such as overcurrent, overvoltage, reverse power flow, over frequency, under frequency. But in modern times, many modern relays will look at an awful lot more than that. So as we said, we got a little diagram there. It's a lookout. It's watching the system, and it's telling the circuit breaker if it needs to operate. As I said, it will be looking at each relay, individual relay in the old days would have a distinct function, looking at just one function. In modern times, as we'll see, it's quite different. So the older mechanical relays, they were much bigger. They had one relay did one job, and this is one of the questions in the UK that's certainly been asked by a lot of people that are not electrically orientated, is why are the service companies selling so much land? Well, the bottom line being is, if you've got a relay that's approximately 6 by 10 by 20 inches, and you've got a three-phase system, if you're looking at voltage, you've got 3 of those. If you're looking at under voltage, you've got 3 of those. If you're looking at over frequency, 3 of those, and so on and so forth. In more modern times, we've got newer digital relays, and these have a different. They're very, very different. The older relays were operated by the system that they were monitoring, so they took their power from the system. So when you needed to test them, you needed quite a powerful test set. Newer digital relays are, as they say, they're digital, so there's very little burden, and they do not need anywhere near the VA that you would have on an old mechanical type relay tester, and therefore they can be smaller, lighter, more portable, and invariably they'll have 3, 6, maybe 8 channels to them. What do we offer? Well, we offer these products here, which are I won't bore and go through them, but we've essentially got three main relay test sets, and these test sets will all test the older mechanical type relays. But if we look at the 200 ADM-P and the new 50 ADM-P, they're a little bit different and they've got a bit more finer control over them. So they cross the boundary and are able to test the older higher burden relays, but also able to test some of the more modern digital relays that have very little burden to them. Our new 50 ADM-P is the one that I wanted to concentrate on today and explain the functionality of it and why it can cross that boundaries. Why can it test an old mechanical relay when a modern digital relay tester wouldn't be able to do that? But we can also have the finesse, as I said, to test the more modern digital relays that have no burden. The new 50 ADM-P was born out of our old 200 ADM-P, and it was designed with one thing in mind, and that was to be much smaller, lighter, but retain that capability and the VA ability to test older mechanical relays, which in most countries you'll find there's still quite a number of older mechanical type relays, and they're still being manufactured and fitted to systems even in modern times because of their reliability factor. So, as I said, the 50 ADM-P is based on our 200 ADM-P, but designed to be super portable. As you saw in that picture, it'll strap your back. So if you're working in a situation where portability and lightness makes a difference, this is an ideal solution. Our aim was to keep the functionality, but to be transportable and much lighter. And indeed, the 200 ADM-P, you're looking at a carry weight and a bigger size and a weight that will be around about 26 kilograms, and we've managed to drop that right down to 15 kilograms or so. So that portability is a significant aspect as to why we've introduced a newer relay test set. Where would we use it and where would we target this specific relay tester? Rail. In the UK, and I obviously would assume that would be the same in some countries, some counties, and in Canada and in the US, where in the UK, the rail companies, much like the many companies in the UK, have sold as much land as they can to up their profits. And what the result of that is very often engineers working on railways can't directly access their substations. So if they want to do day-to-day maintenance, they actually walk anywhere up to 2 miles on foot. So obviously having something that is backpackable is a big advantage. If you're working on underground transit systems or other transit systems where you may be climbing stairs, walking a fair distance, again, that's another place where this unit has come into its own. And the big one for me, having had experience of jumping from a boat when waves are dipping from 1 meter, dropping by 4 meters and then rising back up 5 meters, and you're trying to jump from a boat onto an offshore platform, having something that's on your back with your hands free is a big advantage. As I said, the size is 18 by 15 by 7 inches, and the weight is only 29 pounds, which equates, actually it's lower than I even said. It's a mere 13.2 kilograms. With the backpack and leads, which is the roll that's on the top of the box, that's your lead sets that go in there, and that will bring it up to, again, still only 16.5 kilograms or 36 pounds. So, much lighter than having a traditional test set on your back. The main channel from the unit, we've got a tap, which is the first tap, which is a 3.5 volt tap. It'll give you 16 amps continuous. It'll give you 32 amps for 5 minutes and 50 amps for 1 minute. The second tap, so effectively what you've got is a multi-tapped transformer, if you like, to give you your output. We'll give you an 18 volt tap, and that will give you 4 amps, 8 amps or 12 amps. Now, one of the things I mentioned is relays themselves have changed over the years. As I said, the older electromechanical relays they had quite a burden to them. So if you use a little 30 VA unit to try and inject a current into there, you won't be able to do it. You'll probably blow your test set up because it won't be powerful enough to be able to do that. And traditionally, the more powerful relay testers were too powerful, and there was not enough finesse. And any engineers that are out listening today will, would be familiar with the fact that you quite often will carry resistor packs with you, so that you can add extra burden into the circuit and thus give you a greater amount of control. What we've done is we've put a little limit button on our units. So we hit that limit button, and that is like adding resistance into the circuit, so we get a finer control over the output of the output current that we're trying to inject, and that gives us a much better resolution and a much better control over what we're doing for these low burden digital type relays. We have a auxiliary AC channel in addition to the main output channel. Now the main output channel, if you feed it with 50 hertz, it will give you 50 hertz out, and if you feed it with 60 hertz, which you guys would do, it will give you 60 hertz out. With our unit, we have a second channel, which is totally controlled. It's an electronic channel. So what we've got is the ability to shift the phase from the main output from 0 to 360 degrees. We have the capability of controlling the frequency from 45 to 100 hertz. And we have two voltage taps there. We have a 0 to 130 volts, and we have a 0 to 260 volts. And in addition, on that channel, we can give you current up to 10 amps, and we can give you current up to 5 amps continuously. Obviously, on the 10 amps, there is a duty cycle, but relays are normally very, the trip times 5 to 10 seconds on most relays at the most. This is just a little diagram of how we control that auxiliary output. So as you can see here, we have red lights on the buttons. When we press the button, it will switch. In the case of the first button that we can see here, the adjustment button, we can either select voltage or frequency. Here we can select phase or frequency, and when we turn that on, that will actually adjust whatever we set. And this just gives you a key when you're using our test sets as to what we're able to, what we're looking to control. So with that first configuration, we'll be changing the phase. We'll be adjusting the phase from the main channel and adjusting the phase from 0 to 360 degrees with 0.1 of a degree resolution. In the second, we can the first configuration, is voltage adjustment. Second, as you can see from the slide here, is phase angle adjustment. We can adjust the frequency, and as I said, we can do other adjustments in this aspect here. We also have a DC output built into our relay test sets, and the DC output is effectively acting or replacing the substation batteries. When I first started testing many years ago, if you went into a substation and tested a relay, you would normally connect up to the substation batteries. That's not seen as recommended practice for quite a while. So now what we've done is we've built in a DC voltage, and we can adjust that voltage and give you anywhere from 12 to 220 volts DC, which is capable of then powering up relays that need an auxiliary power supply, such as the digital relays, or if you've got an older transistor type relay where you need to power it up to test the relay. We have also a meter built into our test sets. So we have auxiliary metering, and it's effectively like having a digital multimeter built into the test set. Again, back in the day when I first started, I would rock up with a variac and a transformer and a multimeter, and that's how I would do my relay testing. And obviously using a stopwatch, we would measure the time it took to trip a relay. In modern times, obviously relays trip much faster, so the stopwatch now is out of the question. And obviously having a meter built into the test set so that we can meter whatever we need to meter in respect to that relay, depending on what we're testing, is a big advantage. So as you can see here, we do have the meter built in to the relay test set. And as I said, it effectively is just a digital multimeter built in. And this would just give you an indication of the values that, the multimeter specification that's built into the relay test set. Another aspect that we've got on our test sets that differs from many of our competitors is we have two USB ports. The first USB port is a memory flash drive, and it stores the data to a CSV file. So it means you're not tied to a software. You can use any, Excel or whatever you're wanting to use to read the CSV file. And when we store data, we're storing the time, the date, the main output current, the timer result, auxiliary voltage or current values, auxiliary current current or voltage phase angle from the main channel, and the auxiliary current voltage input frequency. So whatever we've set that auxiliary metering, auxiliary output, whatever the frequency is that's set to, we will know what that is. Then we have a second USB port, and that's basically that we can plug in a keyboard and obviously type in type in any notes. The fact that it's a CSV file also means in the comments we can either put 1, 2, 3, 4 different lines of comment. All we've got to do is put a comment, a comma, and then put the next comment in there, and that will also then automatically, when we download to Excel, it will put it in a fresh box for us. Another key attribute with the memory is it allows us to store the values when we test at different points on a relay. So with the relay, you'll test maybe, so if you've got a 5 amp relay, for example, you'll test at half rated, you'll then test at full rated, you'll test at 2 times, at 3 times, and what you've got is you would then be able to plot that on a graph. Now, many of the manufacturers of the relays themselves will offer you the ability to download their time current curve graph. And that allows you then to overlay your results onto their graph and be very confident whether the relay is indeed in spec or whether there's a part of that relay that's out of spec. And it's very quick and easy to do that. Another key attribute with our test sets, which again is unusual for these heavier power relay test sets, or as they're commonly known, SCITs, secondary current injection test sets, is we have the capability of storing the output waveform. Now, all relays are designed, when you look at a specification of a relay, it's looking at that specification and it's taking it for granted that that relay will be fed with a sine wave. If the relay isn't fed with the sine wave, it's not going to react and meet with the manufacturer's specifications. So if you test a relay and you don't get the results that you're expecting, you don't really know whether or not it's the waveform that's causing the problem. With us, we have the ability to store the data and download that and obviously look at the waveform. So if you're getting strange results, you can look at the waveform and say, yes, indeed, it is a sine wave that we're feeding it, and therefore the relay is out of specification. Or if the waveform was warped in any way, you'll know that the reason that the relay test set is not testing correctly is because the waveform is not correct. Now that could be because you've got a relay that the burden's high and it's deforming the waveform, or it could be that whatever your power supply that's feeding the substation could be interfered with, typically in modern times, with harmonics. And again, not that we're here to talk about harmonics, but I'm sure all of the electrical engineers out there will be aware that harmonics are a modern big problem in a lot of situations. So if you've got a relay substation feeding, for example, a welding factory, you can pretty much guarantee that there's going to be effects on the waveform. The other attributes we got on our unit is the timer. Now the timer, we can either have it as a wet or a volt free. We have various different modes on the timer to allow us to test the different types of relay that we're going to encounter. The first and most common way that you'd have the timer set is on internal start. So what would happen is you'd press the output button. When you press the output on, the timer will automatically start. And when the relay trips, the timer then will stop. And when the relay trips, it will not only stop the timer, but it'll actually turn the output off, so that you're no longer feeding a relay with an input. We then have single contact timer mode, and it's different if C1 or C2. We have two contact. If we go back, sorry, if you look at the picture here, we have two contact sets. And most of the time when you're testing a relay, you're only going to be using one contact set. But some relays will have a start and stop contact set. So you can connect to those and we can test those quite, with no issues. The timer is basically on when the output is switched on, and the timer will start on the first contact change, and then it will stop on the second change of contact. And again, when it stops, it will store the time, and it will also turn the output off from the relay test set. If we operate C1 first, then the output switches off after the first change. If we've got an auto reclosing relay, we can connect to C2 first, and then the output switches off after the second change. And this is viable for when we do things like dropout timing of relay dropouts. And then the contacts will change first time when the relay picks up. The switch off the output manually when the relay is operating. The timer resets when the output's switched off, and the timer stops when the contact changes. The second mode of operation is if we've got as I said, we've got two modes of operation. C1 changes before C2, then it's a standard contact set. So it's a standard relay. Obviously, our previous guest was talking about protection from animals. Now, one of the ways in the UK we've protected our systems from animals and outages caused by animals is we have what we call auto reclosers. And an auto recloser, what it does is if it sees a fault, so you've got a squirrel that we've just been listening about, the tree grows near the line, and then one day the squirrel can actually reach from the tree to the line. When he does that, obviously that will cause an outage. But the minute the squirrel has touched the line, it will drop and the line is now free again. Alternatively, it could be that the trees are growing and the trees have grown and they've touched the line. And the minute they touch the line, the fault that's caused the problem will have been burnt away. And so although the relay, the outage will be there, the problem is not. So in the UK, what we've got is what we call auto reclosers. So to enable us to test those auto reclosers, all we do is we swap over the contacts and we operate the contact set 2 first. And the set automatically now knows we're in what we call mark mode, which is multiple auto reclose timing. So if we've got one of those auto reclosers, and in the UK, the auto reclosers, they will operate up to about 5 times. And after the 5th operation, they go, no, that fault is definite. We need to cut, the power does definitely need to be cut. But most of the time, if it's a tree or an animal that's touched the line and caused the outage, what will happen, the auto recloser will reclose on the fault, sees that the fault's clear, and then the system's up and running. And from our point of view as maintaining our systems and our grids, it means nobody's got to get in a van and drive out there and check because they know that the fault is cleared. Obviously, when you've got these auto reclosers, we've got to have a way of testing those. So what we do, as I said, we connect to C2 first, and when it sees the first change on C2, it knows that it's going to see a number of changes. So it'll be C2, it'll then operate the relay. C1 will operate it to come back on again. C2 will operate, and so on and so forth. Now, our test set will allow to test up to 50 auto opens and closes of those type of relays. And the results then would be stored on a USB memory. As I said, most auto reclosers won't operate 50 times. They'll do 5 times on the trot, and after 5 times they give up and say, no, that line has an issue. We need to go out and fault find on that issue. So when we download those results, this is what we will see. So here we can see the output was switched on, and we can see that the relay then operates and switches off. And when it switches off, it sees that it's now closed. The relay is opened. It'll automatically close that relay again, so we can see that operation time. And when it closes that operation again, the current's still there. The problem is still there, so it closes again, and so on and so forth. And this display, what I quite like about it is Most engineers that are doing protection testing with relays will also do circuit breaker timing, and anyone that's seen a circuit timer display will recognize this as being very, very similar to a circuit breaker timer. The difference is this is for an auto reclosing relay. And as I said, the mark mode results, we can download them, and this is what they would look like if we download and graph them, but we can also view them on the instrument itself using the auxiliary adjustment, and we can go through and it will say T0, T1, T2, T3. So each time, each operation of the relay, we can see how long it took to operate. And that is the same information that we're seeing graphed there. So we can either graph it, or if we wanted to look at the information on site, we can also view that information on site. And then the next one is a timer that is designed predominantly for things like thermal relays. So a thermal relay, if you've got a relay that you need to power the relay up and you need to send the information to it, but the relay is manually shut. So we close the relay. It then, when it sees the current flow, if it's greater than 20% of the range, it will start that timer. And when the relay operates, by changing again, the current output changes by 20%, it will automatically switch off the relay test set and record that time. So we can also test those type of relays. We then have what we call the pulse timer mode, and that allows us to output and control the output so that the unit will only give you 200 milliseconds of current coming out of the tester. Now, we would use this for instantaneous trip type devices, or I would use this if I wanted to set my current through a thermal relay, but I didn't want to inject, mess about for a couple of seconds trying to get the right current, because if I as I'm injecting current into a thermal relay, it will be warming it up. So when I then go to test it, you've already warmed the relay up. So by giving you that ability to limit that current to 200 milliseconds, I can find the level, let's say that I want 10 amps. I can find my level where it is at 10 amps. And then when I can then turn it into the normal timer mode, output that current, and I know that that thermal relay hasn't been warmed up too much to interfere with the results that I want to take. We then have the auxiliary AC timer mode. So that uses the auxiliary AC channel. So if I was not testing using the main channel, but using the auxiliary AC channel, it then links to that rather than the main channel and allows me to do other types of relays. Or if I'm doing dual output, I can then time it not from the main channel, from that auxiliary channel. It's up to me. I've got full control over the set. So essentially, what relays can we test? Now, what we do is the numbers here, we've listed them as the IEEE. Fortunately for us, the IEEE numbers and the ANSI numbers that you use out in Canada and the US, they match up. So this tells you on the relay, when you're buying a relay test set, it gives you the ability to be confident that you've bought the right relay tester for the relays that you're testing, because there's nothing worse than buying a relay tester, going to do some testing, and then finding out that relay tester you've just purchased doesn't test the relay that you want. As I said, in addition to those IEEE numbers, we can also do voltage regulating relays, miniature circuit breakers, and thermal relays. One of the things that's, again, as I said, the fact that we have two channels, and both channels will give us either voltage or current, allows us to test, as you can see, a very wide selection of relays with one little test set. So the summary of that, what is our key attributes with this particular tester? It's lightweight, it's portable, and it's backpackable. You've got the ability to literally wear it as a rucksack. It's got the memory via the USB, and that memory is something you don't see on many mechanical relay test sets. We have the ability to store waveform, and as I said, any engineer out there that's ever had the hassle of going onto site and getting strange results, 9 times out of 10, if your relay's giving you weird results, it's normally because the waveform isn't correct, but you've got no way of telling that unless you happen to take an oscilloscope with you. As I said, we have that second auxiliary channel, which can give me both voltage and current. So by being able to give me voltage and current, I can test a much wider selection of relays. And we have the timing with the smart mode. And the smart mode is something that you'll probably start seeing increasing numbers of relays across the world where they have that auto reclosing facility. And the auto reclosing is to overcome issues where something's happened to a line, but it's not a permanent problem with the line. As I said, it could be that the tree has grown, touched the line. The minute the tree touches the line, the energy will actually blow that branch away. So the problem's gone. But unfortunately, if you've got a relay that just operates, you've got to go out and find that fault. So that gives you a big advantage from that point of view. And then partnered with our relay test set, we have a little, basically a little CT polarity test set. And this is just a very light, simple tester, and it's an ideal commissioning tool. Or if you're doing an upgrade, upscale to a substation and you're fitting new equipment, this is a quick way of being able to tell which way round the CT's got to go. The unit's very, very easy to use. It comes with a proven unit. It's a magnetic back so that we don't have to worry about, we can just literally put it onto the cabinet while we're testing. So the unit can be used for both CTs and VTs. So it's a very handy little test set, giving you quite a lot of tests out of a little 9-volt battery. So in essence, as I say, our new 500 ADM-P is a very lightweight portable set with unique features not seen on other people's sets. I welcome any questions.
Okay, thanks very much, Gary. Good presentation. First question is, what is the accuracy of this test set? 0.2 or 0.5?
We'll need to check, and I will do that right now.
All right.
Are we talking current accuracy?
Yes.
So every aspect of the set, so the multimeter has its own distinct accuracies, and each one of those is in that table that I shown. The general accuracy of the output is 0.1%, plus or minus 2 digits.
Okay.
But I have to be very careful because obviously that's the current output accuracy. If you're looking at the voltage output accuracy, that could be different again. And if you look at the multimeter accuracy, that will be different again. And then the timer has its accuracy. So the best thing to do if you're looking at the accuracies would be to look at the data sheet so that you're checking the right thing for what you want to do. But generally speaking, yeah, the unit is a very accurate and capable unit.
Great. Okay, next question. Why would someone choose the 50 ADM-P instead of the 200 ADM-P?
Purely, I mean, the 200 ADM-P would, if you were a general commissioning engineer, the 200 ADM-P would be the one. If you go to the UK and if anybody out there has got people they know in the UK, if they talk about the 200 ADM-P, it's been a mainstay for what we call the DNOs, which is our nationalized electricity suppliers, and each area has its own company, as it were, and that's been a mainstay of them. And the 200 ADM-P would be the preferred because you've got 2000 VA available. You've still got the 2 channels and all those other features. Where the 50 ADM-P comes into its own is purely for size and weight. As I said, I had the misfortune a number of years ago, and I do say the misfortune in the very strongest terms. We have a lot of offshore windmills, wind farms, and I thought it was great because I'd never been to a wind farm before. And on the day I went out, it was probably a force 3, and it was choppy. And I got down there and I looked at the waves and I thought I wouldn't have to go. And jumping from the boat, you're harnessed up, so in theory you're not going to go anywhere, but still you take your life in your hands when you jump off that boat onto the ladder and climb up onto the wind farm. It's scary, and I was quite pleased that I had a 50 ADM-P and not a 200 ADM-P on that day, that's for sure.
All right. How do you save the test results on the 50 ADM-P and look at them later?
So as I said, you've got a USB flash drive. On the actual tester itself, and I sound like I'm being sarcastic now, you turn the selector to store data. And when you press a button, it automatically, every time a test is carried out, it will store that data. And if you want to input comments, you use the keyboard and type in your comments for that test, and then you carry out the next test, and again it will automatically be saved. When you press the on button and you turn, either press the off button, or the unit automatically detects the relay tripping and switches off the current, it stores the data automatically, and you type in the results, or you type in comments, whatever that may be.
Okay. What next question? What kinds of relays can the 50 ADM-P test, and are there any it can't?
The ones that we can test, as I said, was listed on that slideshow. If I go
Yeah.
back and share that again. So we do list in our data sheets, and you'll find on both PSI's and our website, the data sheets will be there available. And as you can see here, we list out quite clearly what relays can be tested. And the relays are designated. In Europe, it's the IEEE number. But as I said in the presentation, in the US and Canada, they use what they call the ANSI system, but the two are exactly, 21 on ANSI and 21 IEEE says distance protection relay, one phase at a time. If we look at 85, it's a pilot wire relay. They'll be the same. So those numbers equate to your ANSI numbers. Now, when you're looking at a relay, the data sheet of the relay will designate what the ANSI number of that relay is. The most common relay will be typically is volts and frequency, which is number 24, 2759, which is under and over voltage relays, and I can't find the current relays, but current relays is undercurrent power 37. They're the most common ones that you're going to see. And then up with those will be directional relays, which are quite common these days as well. But the relay that we can test, we list out on our data sheet, so it's very clear. So all you've got to do is look at your relay, see what ANSI number your relay falls under, check our data sheet, and it will tell you whether or not we can test that. Obviously, if you've got a 100 amp relay and you buy the 50 ADM-P, you won't be able to test 100 amps because it's only 50 amps, but it'll tell you the type of relay that we can test.
Okay, great. Next question. How would you compare your test set, the 50 ADM-P, with the equivalent Omicron or ISA or other test set in terms of cost and technical preferences or
Right, so
performance?
if I start with Omicron have gone down the route of being automated, and they've they are a digital relay test. They are a digital relay tester company predominantly. And if you look at the Omicron, you'll be paying £55,000, and you'll have 6 channels, each with a massive 30 VA per channel, which is great for digital relay testing. If you come across then a mechanical relay, what will happen if you try to do it, and I have tried to do this in my previous life when I was a distributor, I thought I'd be able to push the relay set, and I remember the guy sarcastically saying, when the blue smoke comes out the top, what does that mean? In terms of ESA have what they call the T1000, and that is a very comparable to our 200 ADM-P. I mean, in essence, you've got ESA with their what we call skits, secondary current injection test sets. And they have got a 2-channel unit like us. Mega have the Circa 780, which is a 2-channel unit like us. But there's some distinct features that I've covered today that we have put into our test sets that others haven't, because they kind of look at them as they're an older electromechanical tester, or a skits. And a skits is one step forward from a variac and a stopwatch, and we've taken that one step further again, and where we've positioned ourselves is to bridge the gap between a traditional secondary current injection test sets, which are powerful, but you can't control very easily, and between the modern digital relay testers, which don't have enough power if you've got a mechanical relay. In terms of pricing, we would be around the same sort of price as ESA or Mega, those sort of prices. Omicron, as I said, I wouldn't make a comparison between us and Omicron because they literally, their test sets obviously are much more expensive, but they are aimed at these very the modern digital three phase multi-channel relays. So our unit is not aimed at that marketplace. It's aimed squarely at the electromechanical and going into single phase digital relays.
Okay. And then there was a mention, someone mentioned, Nadeem mentioned that please upload on YouTube or on your website some 50 ADM-P testing videos. Good point.
It's a good point, and I'll be honest with you, that is one of the things we are in the process of doing at the moment.
Yeah, I've been mentioning to a number of people that the what is videos are not as attractive as how-to videos.
The problem with relay testing is it's very specific, and there's not a lot to see, especially with a digital relay. You don't see anything and there's nothing to show, so
Mhm.
it's very difficult to actually make a video on relay testing. If you're showing the tester, it's much easier to show a video of relay testing as an applicational aspect, but not as a this is our test set and this is what it does. All you can do is do a video of your tester and show outputting. But if you come to test a relay, it would make for a very boring video, unfortunately. And
Do,
that's the issue that we're trying to overcome at the moment. Finding a way that we can show people the tester in an applicational way.
do you have a YouTube channel?
We do have a YouTube channel. I'm not
Okay.
I'm not sure how many videos are on there. There's very limited videos on there at the moment. As I say, when I came to TNR, it was a company that when I came, we were very much centered around our traditional values of selling to the DNOs in the UK, where we're very, very strong. And when I came in, one of my tasks that I gave myself was to make us a little bit more worldwide.
Okay, great. Well, everybody, you can you can contact Gary directly. I put his email address into the chat, and I've also given you the presentation material. Mark's email address is also in there, as well as PSI's information. So thank you very much, Gary, for the excellent presentation. Thanks for those questions. Thanks for your answers. And thank you.
Thank you very much.
Okay,
Thank you,
great.
everyone.